All right, welcome to the last concept of this whole JT probability. Now, you realize that the concepts are not a lot, but it's because the concepts are really not a lot. But it's more so of the application of all these concepts into the exam questions. So I hope that all the example questions that we have run through throughout this whole entire series has been a good practice for you. And if you like more practice, more exam questions, exam level top 10 explanations just like this, make sure to click the link in the bio for the link to if you want to get access to my library of more questions and more recordings. Okay, go ahead and check that out after this video. But now we're going to talk about the probability tree diagram. And it's a concept that is more like an application technique. But I wanted to go through this because it's so common to the point that I think that if I don't include this, it's not complete, right? So what exactly is a probability tree diagram? And when do we use it? So we always use this when there are multiple events happening in order. Okay, so let's say I have the event A, B, C, right? They all occur in order. And let's say the probability of A happening is 0.5, 0.5, right? Let's say the probability of event B occurring is 0.8, 0.2. And let's say the probability of event C occurring is, let's say, 0.4 and 0.6, right? So happen, never happen. Right, and then I'm just going to copy this whole thing here and paste it here, right? Just to save us a little bit of time. Okay, so I just paste this here. Okay. So look, with that said, whenever there are multiple events occurring in the same order, happening in order, it serves you very well to draw a probability tree diagram because you can visualize the different paths, different possibilities of the different events occurring in order. So just a recap, everything starts from a main branch over here, right? And then this is A, B, and C. So I'm just going to draw my starting brush to be a little bit skinnier. Now the probability of A occurring would be 0.5, 0.5, right? 0.5, 0.5. This is occur, no occur. Now, after event A occurs, right, when it comes to B, there are yet another two possibilities, right? It can occur or no occur. But same for the bottom, right? Given that A has occurred or not occurred, afterwards, whether B occurs or not, it's not affected, right? It's independent. So here can be occur or no occur. Then here will be 0.8, 0.2, 0.8, 0.2. And then last but not least, when you go to C, there's another two possibilities here, right? It can occur, no occur. Same thing here, right? You can split here, right? So this is occur, occur, no occur, occur, no occur, and then occur, no occur, and then occur, and then I just draw it down a little bit, no occur, right? Just to save us a little bit of time. And then over here is 0.4. 0.6, 0.4, 0.6, 0.4, 0.6, 0.4, 0.6. So the thing is that one full progression is starting from here and then you trace the branch, right? So this is one full set of possibilities. This is one. Another full set will be here. A third one will be here. And the fourth one will be here, right? So you realize that you can do many, many different types. And you realize at the end, we have 1, 2, 3, 4, 5, 6, 7, 8 different possibilities, right? There's 8 different possibilities because it's 2 to the power of 3 because we have three different so-called branch out points. And it always be 2 over here because there's only 2 possible outcomes, right? Occur or no occur. 2 possible outcomes only. That's right, only here, right? So the thing with possibility tree diagram is that the sum of all these different outcomes. So I'm just going to write the summation symbol here. The summation of the probability, right, of n, whereby n is 1 and it goes up to 8, right? It will all be 1 because the thing is that at the end of each tree, right, all the nodes, you can think of them as leaf nodes. The probability when they all add up has to be 1 because the only 8 possible outcomes, right? There's no other possible outcomes already. So all these will add up to 1. Okay. And if whenever you draw a tree diagram, if yours doesn't add up to 1, then there's some problem. Okay. So that's pretty much it for the possibility tree diagram. It's really just a recap. And I feel like this is such a useful tool. Especially in the questions that you see later on that we practice. Okay, so make sure you understand this before you actually try the question, and feel free to play back whatever I just said if you need. If not, here is an example question. Feel free to pause this video right now to go and tackle the question. If not, we will proceed to tackle the question right now. Okay, so for this question over here, let's just annotate it. A prime over here is complement of, which means it's the opposite of A. So if the probability of A occurring is 1/3, the probability of A not occurring will be 2/3, right? Because it's either yes or no. Same thing here, right? Here will be 2/3 and here will be 3/4. So now we need to look at this. They want us to compute the probability of P prime given that A has occurred. So remember the formula, this one would be P prime intersect A given that A has occurred. So what is P B prime intersect A? That means this one will be B prime and P, right, over PA. So we can see that this over here would be 1/3 times 2/3, right? Because we are following this branch over here over PA, which is 1/3. So when we actually multiply them together, we end up with 2/3 as the final answer over here. Okay. And next, what is the probability of B? Now, the probability of B, you can see that B over here has two different branches, right? One possible route to get to B will be this, and then another possible route to get to B will be this. So the probability to get to B would be summation of the two different routes, right? Route 1 and route 2. So this one would be A followed by B, and then PA prime followed by B. So it will be 1/3 times 1/3 plus 2/3 times 1/4, which eventually gives us a value of 5/10. Okay, so this is just a very simple example over here to run through all these concepts. And if you want access to the rest of the other questions that are more exam type of standard, make sure to click the link in my bio to check out the library if you want to get access to that. And also, we have come to the end of this chapter. So if you want to move on to the next one, please do so. And also, if you want to sign up for my math tuition classes at my center and get tutored by me personally for H2 Math, make sure to WhatsApp the number on the screen over here. If not, congratulations for making it until the end of this very chapter, and I'll see you in the next chapter.